Good afternoon, everyone. On behalf of Sartorius, I would like to welcome you all to the Optimizing Freeze and Thaw Processes, Choosing the Right Tools for Cryopreservation Success webinar powered by Sartorius. My name is Nurul, a conference producer at IMAPAC, and I will be your host for today. I would like to share a little bit about us. IMAPAC strives to be your one-stop shop for the biopharma industry's business intelligence and networking opportunities. Over the past 15 years, we have established ourselves firmly as a trusted organizer of high-quality biopharma B2B conferences and exhibitions in Asia Pacific and beyond. In the recent 5 years, we have exponentially expanded our portfolio to include digital marketing solutions, market research reports, and our webinar series. Today, we are hosting the Optimizing Freeze and Thaw Processes, choosing the right tools for cryopreservation success, where you can discover how to select the right tools for your freeze and thaw process, compare bottles versus bags, and leverage Celsius and TCO tools to enhance efficiency, sterility, and cost-effectiveness in bioprocessing. So, here's a quick introduction on Sartorius. Sartorius is a leading international partner of the biopharmaceutical industry and the research sector. Known for its innovative solutions, Sartorius specializes in providing cutting-edge laboratory and bioprocessing equipment, as well as services that enhance the development and manufacturing of pharmaceuticals. With a strong commitment to quality and sustainability, Sartorius supports its clients in making scientific advancements that improve human health. I would like to express my heartfelt gratitude to Sartorius and our distinguished speakers for making this webinar possible. Thank you so much for your time and commitment to be part of this webinar. And to all attendees, thank you for taking the time out to be with us here today. Before we start, here are a few housekeeping announcements. We strongly encourage everyone to submit your questions by using the Q&A function at the bottom of your screen. And please ensure that your name is visible so we can follow up with you directly. Our speakers will be answering them during the Q&A session right after the presentation. So now, without further ado, I would like to introduce our speaker for today, Stephen Woodhouse. Stephen Woodhouse is the product manager for Freeze and Thaw at Sartorius. He holds a master's degree and a PhD in biochemical engineering, with research focused on improving product titers in microbial fermentation. Stephen joined Sartorius in 2016 and has since worked in various technical field roles. Most recently, as product specialist for Freeze and Thaw in the EMEA region, providing application and project support to customers. Since 2024, as a product manager, he has been dedicated to developing robust solutions for the freezing and transport of valuable drug substances to the market. Most recently, this has been achieved through the expansion of the Celsius FFT FFTP portfolio with the FFTP 2 liters and the completion of the second generation product launches. So now, Stephen, the floor is now yours.
Thank you. Welcome everyone to this webinar on the benefits of single-use bags in replacement of bottles for freeze and thaw applications. As mentioned, I'm Stefan Woodhouse, and over the next 45 minutes or so, I'm going to be discussing bag applications for freezing drug substance. Now, I think it's really good for us to start at when exactly do you freeze API, so active pharmaceutical ingredients. Now, we should really see it as freezing is something that you use everywhere in drug substance production. Right at the beginning of the process, so during cell banking, your cells are frozen. Then throughout the downstream process, various intermediates are frozen. Your drug substance is frozen, and sometimes even your drug product is frozen. And as you can imagine, as we go down this process, the value of what's being frozen also increases. For the purposes of this webinar, we're going to be focusing on the end of the bioprocess. So here we're going to be talking about bulk drug substance, which is typically frozen at minus 20 degrees and below. When I talk about this step of the process, why are we freezing drug substance? Well, drug substance is typically frozen because you're halting the biological clock of your API. The idea here is that it allows you to decouple your drug substance manufacturing site with your final filling site. This optimizes production and allows for a global network of production. I don't really need to tell you, but any leak in these drug substance containers during transfer from drug substance site to drug product site, or even if you're manufacturing drug substance and drug product in the same site, a leak is incredibly expensive. And here we can be talking €1 million per bottle or even more. And as a result of this, we need to have containers that are specifically developed in order to prevent this kind of leakage. There are plenty of solutions out there for doing this. We have bottles on the market. We have stainless steel vessels which can be frozen. So these are called cryo vessels. We have single-use bags that are just on their own in a freezer without protection. We have single-use systems which have dedicated protection for freeze and thaw, and a few other custom solutions on the market. Today, we're going to be focusing on bottles and custom design solutions. In order to get some perspective as to where we're starting, we're going to be talking about the conventional freezing process in bottles. When we talk about freezing in bottles, we're talking about this rough process. So we have a distribution tank going into a laminar flow hood where multiple bottles are filled in a, well, more or less sterile manner, an aseptic manner. And those bottles are then closed in the laminar flow hood, and they are then transferred into a freezer. The freezer can be whatever freezer is available. So this can be a cold room, this can be a blast freezer, it can be a standard upright freezer, anything. Those bottles are positioned in there, and when those bottles need to be shipped, there's not normally a dedicated shipping solution. They are normally put into any kind of container that's available, typically cardboard shippers off the shelf, filled with dry ice, and then shipped. This is quite a complex process. It's incredibly manual, and all of you that have worked in a lab know that filling individual bottles under a laminar flow hood is not the most pleasant process, and it requires skill, a lot of time. The storage requires a large footprint, and the shipment is a bit of a mess. This leads us to describing the challenges of dealing with bottles. Now, first of all, as mentioned, we have the issue of aseptic processing. So you need skilled operators to deal with the bottles within the laminar flow hood. That laminar flow hood even needs regular maintenance, and all of this is a complex and manual operation. We also have the issue that the bottles don't necessarily stay integral, and so they can break during the frozen shipping. And this, of course, affects whether you have a sterile process or not. And then, speaking of sterility, we also have the actual filling of the bottles that, okay, yes, in a laminar flow hood, you are acting in an aseptic way, but due to the fact that you're dealing with a lid that is screwed on, there's always a risk of that lid providing contamination to what's inside your bottle. And so there's particularly high risk of contamination with bottle processes. Moving on to your critical quality attributes, we also have issues with process control. Bottles don't typically scale very well. This is because the geometry changes of the bottle, so your freezing times will disproportionately increase as you scale up. You also have maximum limits on the size that bottles can be bought in, and there's no particular way of monitoring your bottles. You can insert probes into these bottles, but then you've lost your sterility. And so you cannot monitor individual bottles, and you cannot monitor the filling process or any of the steps in between. It is very much a hands-off approach in terms of data. You also have limited product control itself. You don't have very good heat transfer efficiency. Bottles are not the ideal shape for freezing. So you have a relatively slow freezing process. And that slow freezing process can lead to what's called cryoconcentration, which can then affect the quality of your product. And then storage and shipping is the final kind of step in this, where storage, as mentioned before, Bottles are bulky. When they're in this more cuboidal configuration, they can be relatively efficient, but still you have a lot of wasted space in your freezer, especially with cylindrical bottles. So you lose out on freezer space, you aren't able to stack these, and it makes adding and removing bottles from your freezers complex. And all of this increases the footprint of your process, which of course increases cost. When we ship these containers, we then reach another point, which is that there are no dedicated shipping solutions for bottles, and this just makes the whole process of shipping a lot more complex. And as a result, you also don't have any shipping qualification or any kind of characterization other than what you yourself have done in terms of validating your process. But we, of course, understand as a company that it's not easy to just change from an existing process to another. There's a reason why so many customers have used bottles for so long, and it's because it takes time and costs money to change your material, so your product contact material. There's a lot of additional testing that needs doing, so validation studies are needed, stability tests, extractables and leachables, all sorts of things. And then there's also a fear that this will actually increase costs overall. It's no secret that bottles are quite cheap. This is why they've existed for a long time. And single-use containers are comparatively more expensive. We also know that it's not so simple to change SOPs and to train up operators. And we all know that the process is only as good as the training of the operators in that process. So this adds another burden to change. And then finally, there's a fear of additional infrastructure. You are already set up to handle bottles. You already have your equipment. So it's not necessarily a pleasant thought to think of adding new equipment in, new ways of doing things. And these are all hurdles to change. Now, we wouldn't be doing this webinar if we didn't have solutions to all of these challenges. And generally speaking, we believe that a modern single-use solution should address these things and be a closed, sterile, and ready-to-use system. It should be adaptable to multiple freeze and thaw methods. And what I mean by this is not just cold rooms, not just blast freezers, but also plate freezers, for example. And in terms of thawing, plate freezers and other types of freezers. The solution needs to be scalable. We can't max out at volumes of 10 liters. We need to be qualified for a full life cycle. So we don't just do testing of the product on site during validation, but to be pre-qualified to make sure that it can handle all of the stresses that a container goes through, from filling through freezing, shipping, etc., etc. And it needs to be down to minus 80 degrees, which is frequently the standard for biologics. And in order to maximize space, it also needs to be designed for bulk processing, storage, and shipping. And what I mean by this is we need to have something that can optimally take up the least amount of space when we go to large volume processes up to 120 liters and above per batch. Now, going back to all the challenges that we were seeing, I now want to go through how we can address each of them. And we'll begin with aseptic processing and the need for laminar flow hoods. In a single-use process, we no longer have the need for these laminar flow hoods. We can take all of this out of the hood and work in a normal grade C or even grade D environment. And this is because we have sterile connectors on pre-sterilized, ready-to-use bags. This means that the bags can be taken into your filling suite, connected up directly to your distribution container, and filled. This means that the only additional training that's required is how to use sterile connectors and how to handle bags. It takes out all of that training and complex burden of dealing with the laminar flow hood. Once the bags are filled, the rest of your process remains the same. So you are able to just freeze the bags, ship them, store them, thaw them, etc., etc. In terms of what I mean for the ease of handling in all of this, the bags are ready to use. You simply remove them, you connect them, and you freeze them. And as mentioned before, we're compatible with all types of freezers. So we have conventional freezers here. What I mean is we're talking about your cold rooms, your upright freezers, your chest freezers, all of these kind of things. We're also compatible with air convection, so this is blast freezers. And then finally, for really fast freezing and thawing, when it's really critical to your product quality, we also need to be able to adapt to plate freezers as well, where freezing and thawing is done by conduction rather than convection. Going back to the robustness point, our bags have been tested throughout a whole life cycle. And I'm going to take a moment just to explain what I mean by this. So when our bags were developed, we did an ergonomic study where we tested exactly how our bags are used and what shocks they experience during their entire life cycle. And here we placed accelerometers on some bags and we handled them all the way through their life cycle. So this is all the way from opening the packaging to filling the bags, freezing, shipping, thawing, draining. All of this, we measured the acceleration that the bags undergo in very cautious conditions, in normal conditions, and fast conditions. And fast conditions is where we are saying that the operators are under severe stress, a deadline, they are really pushing things to the limit. So they are acting outside of normal SOPs. We took the data from these accelerometers and we used that to design a test methods to replicate the accelerations that bags experience. And this meant that we could then replicate the entire life cycle with a custom-made device to completely replicate the worst case scenario in terms of handling conditions of frozen bags. What this looks like is that we have the entire process, filling, multiple freeze and thaw cycles, shipping at -80, liquid handling, and finally draining, all covered in the worst case scenario for any type of operator and shipping in any environment. And this is supported by 100 plus 12-liter containers, all being successfully subjected to these tests. We didn't just do 12-liter containers, we did all container sizes, but this is your worst case scenario with really heavy bags. In terms of the shipping tests, we kept with industry standard. We did the ASTM D4169 shipping tests to make sure that we went to the worst case scenario. We did the assurance level 1 tests. And so we made sure that even at -80 degrees, the bags could handle a full shipping process. This is from truck shipment through aircraft through another truck shipment. This is to give extra assurance that the bags can survive an entire process. Moving back, we're now going to address the container closure integrity and that risk of contamination when we're talking about the filling of bottles and the likelihood of contamination whilst closing those bottles. We've already talked about the fact that sterile connectors are able to mitigate one of the risks, but another risk that's mitigated is the fact that all of our bags are tested in a bag chamber leak test machine, which detects any defects in the bags. And what we're talking about here is gross defects, so any holes that you might see. But because we're talking about bags that are going to be used in the most critical application, so this is for drug substance, we also have an integrity test. The difference between a leak test and an integrity test is that an integrity test is correlated to microbial ingress. So we use helium here to test for these defects, and these defects can be down to 2 microns. And every single bag is then helium integrity tested to make sure that it remains integral during your filling process. Because the bag will arrive sterile, we want to make sure that it remains sterile. Moving on to process control. We talked about scalability and the actual impact to product quality by limitations in heat transfer and cryoconcentration. So first of all, speaking about scalability, we have containers that go from 2 liters all the way up to 75 liters with the same film, the same overall design and technology, the same overall geometry, and we have the ability to also remove the operator from the process if needed. So these containers can also be palletized to further reassure you that the bags are being handled correctly. And there's complete uniformity across the platform, whether you're using a few 2-liter containers or stacks of 75-liter containers. This means you've got scalability all the way up to 300 liters per pallet. In terms of control, I discussed before the effect of cryoconcentration. Just as a quick reminder for those of you that don't know this particularly well, cryoconcentration is where during the freezing process, everything that's dissolved inside a solution gets concentrated towards the middle of the container. This is because as ice forms, it pushes everything towards the middle during the first freezing process at 0 degrees. It's only once the glass transition temperature of the product is reached that this concentration stops. Now, the wider the container is, so what you have to imagine, this is a distance from the edge of the bottle to the center of the bottle. The greater that distance, the worse this concentration effect is, and for particularly sensitive molecules, this can be a problem. Now, you have to imagine that in a bag, you have a flat geometry, so this concentration effect is already reduced, but then we can further reduce that effect, if required, by introducing faster freezing processes. What I mean by that is, if we talk about freezing in a plate freezer, we not only freeze quickly due to the distance between the freezing fronts, but also we're able to freeze very quickly due to the type of freezing employed. And this can all be enabled via bags. Finally, I want to address the storage and shipping point regarding the overall footprint of the process and the stackability, the shipping, and the qualification. With regard to stackability, as you can see on the left, our containers, so in this case FFT, are stackable and therefore can easily be positioned in freezers and added and removed simply. When it comes to storage, they can either be stored as you see on the left, or we have shippers which can be used for storage where you can palletize up to 10 bags at a time. So this is up to 120 liters at a time, and transfer this pallet in and out of a cold room, for example. As mentioned, this is a shipper, so that shipper can then be shipped, and it has already been qualified, as mentioned before, according to ASTM D4169 for shipping down to -80 degrees. The fact that it's palletized means that it's, of course, nice and simple to transfer around a site. And we've also done characterization work with Prooftainer. So this is the shipper from Envirotainer, where we've done explicit testing with their shippers, but we've also made sure that it's compatible with all other main brands on the market as well. It should come as no surprise at the end of all this that the solution to all of these problems is our Celsius FFT with SafeCore technology platform. The technology here is a bag within 2 protective shells. So we have an HDP shell, that's the white bit around the edge, and a copolyester plate, that's the SafeCore technology in the middle. This particular design means that you have product visibility during your handling. This is particularly important after thawing, so you can check for aggregation of the product and to make sure the product is also fully thawed. It's nice and easy to clean by having smooth surfaces. We have robustness down to minus 80 degrees, which has been tested in the qualification that I discussed before. The design overall is to enable as easier operation as possible. And what I mean by this is if you look around the side of the bag, you can see specially designed tube holders which allow easy access to tubing and easy stowage of tubing. Tubing is always a vulnerable point, so we want to make sure that the tubing is protected, but still easy to access. And this design and how open it is also means that multiple disconnectors and connectors can be used. So this will not only use the Sartorius Opta connector, but it can also use all other sterile connectors on the market. We then want to make it easier for your quality teams in order to take their samples. And for that, we have a sample bag cover accessory. This is to hold 30 milliliter bags and 100 milliliter bags so that they can be shipped in combination with your drug substance container. And finally, we have multiple ways of labeling the bag with this accessory at the front, this yellow accessory at the front for labeling, or as you can hopefully see on the bottom left and top right, there are holes for cable ties as well. All of this is on top of the benefits that I was mentioning in the previous slides on how we have improved from a bottle handling process through to a bag handling process. If you remember at the beginning, I was talking about multiple different factors that may put you off. Hopefully, I've addressed all of them, but the one remaining one is cost. And something that we are very aware of is the cost of bags and the comparatively low cost of bottles. And so I want to take a little bit of time to go through this as the final hurdle, so to speak. We have a total cost of ownership tool that we can use to help you assess the cost of a bottle process versus a new process with bags. This is just a summary slide of one of those assessments. It's a very detailed slide and requires input regarding cost of the drug substance, the type of bottles being used, how many bottles are used, time spent in the process, etc., etc. It's a very detailed process. But at the end of that detailed analysis, we end up with this sort of conclusion. And here we start off with, first of all, the CapEx investment. Now, it should come as no surprise that the CapEx is the negative part of this because you will either already be using your existing freezers and therefore not have any need for new CapEx. And new freezers, especially if you invest in a whole platform or plate freezing technology, that will be additional cost. And this is something that we're well aware of. Excuse me. But these costs are then balanced out by various other factors. Now, we need to take into account how much product is lost during a traditional manufacturing process with bottles. This is loss in two different ways. This is physical loss. So this is loss from leakages, which is, of course, the most apparent form of loss. But we also need to consider loss in drug substance activity, which is also really critical. And we can help you study exactly how much activity loss is happening when you're freezing in bottles compared to freezing in bags or doing a controlled plate freezing process in bags. Because that drop in product activity is, of course, also product loss. As a result of these kind of tests, we can attribute this to a particular cost. However, we don't just think about the cost of the manufacturing value, so how much time and cost has been lost in the manufacturing process. There's also very much the cost of the market value of the product that's been lost, which is huge. And this is where we really start to see a differentiation between the cost of bottles and bags. And this is on the purely product loss side. We also need to consider the actual cost of manpower as well. And this is where we talk about processing times and manufacturing costs of the product. That in order to maintain laminar flow hoods, those laminar flow hoods take up space that could be utilized for other things. So removing them opens up a facility to introduce more equipment because single-use products enable reuse of the same manufacturing suite for different products. You maximize the usage of your clean room space rather than having a dedicated space for one product that needs a full clean down between manufacturing runs or between campaigns. So you have this aspect in terms of the footprint and the laminar flow hoods. But then you also have the costs associated with purely the operator time required in order to make the product. We estimate that the handling time of bottles compared to bags is disproportionately high, even for skilled operators. And here we're talking about savings of a good 20 plus hours per batch in terms of an operator handling bottles versus handling bags. This may seem quite extreme, but what you have to bear in mind, we're factoring in the time it takes to clean the laminar flow hood each time, the extra care that needs to be taken when filling a bottle and closing the cap, making sure everything is clean. With a bag, you are talking about 20 seconds to connect a bag to a distribution line and then filling. This is a lot quicker. Even if those bags are welded, and where welding times come to the 1 minute, 1.5 minute range, we're still going much faster than individually filling bags. If you then start to take into account that we also provide automated filling machines for single-use bags, so this is our aliquoty for FFT, this can then further reduce these times. And these times then really add up to being 400 plus hours per year. And labor costs are, of course, one factor of this, but the time that operators spend doing this, they are not doing other things. So even if your labor costs are comparatively low, which isn't particularly common in the industry, but it can be, even if your labor costs are low, your employees are still incredibly valuable for what they can do whilst, or what they could be doing whilst they are filling bottles, cleaning laminar flow hoods, etc., etc. So all of this together results in real savings when it comes to moving a process from bottles to bags. The main driver is, of course, the product loss reduction from the better recovery and decreased risks overall. But even if we discount those losses, just the overall improvements to the process in terms of time, labor, and waste, we still see savings. And that additional capex that we see on the top right of the screen, that capex is quickly taken up in savings over the course of 8 to 16 batches, depending on your manufacturing costs and the value of the product. And as mentioned before, overall, this comes to around 400 hours per year that are saved. If you're interested in this, please reach out to us. We have a total cost of ownership tool where we can go through this process. And as part of this, we can also start assessing the freezing behavior of your product. It's something that we know is frequently secondary during the development process, that the quality of the product is seen as secondary when it comes to freezing. Formulation is prioritized, but what we can do using our scale down tool, so this is the Celsius S cubed, we can actually check exactly what impact freezing has on your product and see what improvements could be made by switching to other processes, whether this be a straight swap in terms of a bag process. So this is the Celsius FFT in your existing freezers. Or if we go to a more high-end process with Celsius FFTP, so that's for plate freezers, and then seeing what improvement you can see from fast freezing times and thawing times in a plate freezer. So I really encourage you to start looking into this, whether it purely be from a total cost of ownership perspective or from a product quality perspective when it comes to freezing processes. Now, to summarize everything that we've discussed, I hope that you can see that the FFT and FFTP with SafeCore technology provides robustness by design. So we've properly characterized these containers at low temperatures and tested them to make sure that they can handle everything that you throw at them. I know I only talked about it briefly, but they have integrated tubing management and sterile connectors, making them really easy to use and quick to use with the sterile connectors and easy to integrate with the cleanability. The handling and shipping qualification is something that will hopefully be a game changer in terms of the validation of a new process, where we take that burden from you and you can leverage all of our data. It's not the products that are valuable, it's the data that comes with them that's valuable. And you can then implement this in your own PQPV. We've also shown you that you can get equivalent or better storage density with bags because we have the ability to stack them, palletize them, store them, and ship them. And finally, that we can go from, 500 milliliters, that's in a 2-liter container, all the way up to 300 liters, so that's 75 liters palletized, all in the same material, all in the same container concept. And as I was mentioning previously, we can also do scale down studies down to 20 milliliters because we're aware how valuable your drug substance is, and you don't necessarily have product to waste in doing studies. So we can even do scalability studies with our small 20 milliliter, 30 milliliter bags down to 20 milliliters in order to test exactly how your product behaves. And that means we get full scalability from lab all the way to blockbuster scale. And the concept here is a robust and simple method of handling your cold chain. And this is what it looks like. We have secure bags in FFT, FFTP. They can be adapted to any freezer type. And here we say that we can adapt to your exact freezer that you have. Nothing needs to change in your process. Or if you want to improve freezing, we have our FFTP plate freezer. That's the image below. We have the ability to store in our bulk shipper. We have the ability to ship in our bulk shipper, or when it's smaller quantities, box shippers, which are cardboard shippers. We then have the flexibility to thaw in any method, or again, using a plate freezer, you can thaw in a controlled way. And then finally, the containers can be drained, completely disassembled, and the components recycled, because this is, of course, important in the overall life cycle of the product. And if there's nothing else to think about in this and to take home with you, please bear in mind that there are huge benefits of single-use containers over bottles, and these are reducing your risk by being more robust and easier to work with than bottles, increasing operational efficiency by reducing footprint, freezing faster, and being easier for operators to use, a simplified cold chain with a reduced validation burden. This is due to all the testing that is done on our containers on our end to save you doing that testing yourselves, and overall bringing down the total cost of ownership, which hopefully I've demonstrated, but we are very happy to work together with you to assess the total cost of ownership in your own process. And I think in any of these sorts of webinars, I, of course, will promote our technology and strongly believe in it, but I think the real proof is what the market thinks of the technology. And since we launched in the pandemic with our FFT and FFTP containers, We've sold over 100,000 of them, and these have been used in real critical applications. This is in COVID vaccination processes and also for valuable drug substance of MABs and FABs. And in all of this, we've demonstrated really superior operational efficiency. Now, I hope you've enjoyed this presentation. I'll be happy to take questions, but I'd like to thank you very much for your time and attention. Okay, goodbye.